Hi, my name's Patrick. We're going to be doing the pre-lab video for the dilution lab for you today. There's some new materials in here that you may not have seen before, so we're just going to walk through them individually, one at a time, show you what they are, and show you how to use them, so when you get to do your lab, probably go a little bit smoother here. First thing we're going to talk about that you'll see in your lab book is this pipette bulb. We have 3 different marks on here. The first one is labeled A. This is for your airflow. You have an S, which stands for suction. You have an E out here, which stands for expulsion, which I will show you how we use that with the pipettes. All right, we have 2 different types of pipettes. We have your standard pipette, which, as you can see, has multiple different markings on it in milliliters. And then we have the ones that we're going to be using today, which are volumetric pipettes. The major difference between these two is a volumetric pipette only has one line at the top, and that stands for whichever measurement that you can read here on the end of the pipette, which in this instance, it stands for 8 milliliters. So to attach these, what you're going to do is you're going to take your pipette, and you're going to take your bulb, and you're going to put it on the non-pointy end. Now for your lab, it's going to require you to get a stock solution. The most important thing for your stock solution is to make sure that you bring your own beaker and do not pipette directly out of the stock solution. So what we're going to do is we're just going to pour a small amount into here for our stock solution. Now, the main thing you're going to see here is if you try to squeeze this, you're not going to go anywhere with it. So what you have to do is you have to hold the A and squeeze, and this will start your suction up for you. So to start your suction, you want to insert it into your solution here. Make sure you're not on the bottom, and you want to make sure that you're just in here, and then you just push and hold the S, and the fluid will start to come up the pipette. Now you'll notice the first part here will come up really quickly until you get to this bulb where it'll actually go pretty slow. But as soon as it gets above that bulb, it's going to come to this line right here really, really quickly, and you want to make sure that you let go of your S right when you get to it. And same as everything else, you want to make sure that you're a little there. Now if you go a little over, that's just okay. You just come back out and you push the E for expel until you get right on your line here. And then this will give you an exact measurement of 8 milliliters in your solution, which then you can just transfer over into your volumetric flask, which also, like your volumetric pipette, it has one measurement and one line. And every time you're working with a pipette, you want to make sure that you're keeping it straight up and down, and you're not letting it go to the side or anything spilling out on top of you. So to expel, all I'm really doing is holding the E, and it's just letting everything out to the very end here. All right, now that should clear up pretty much everything you have about using the pipetters and the pipette bulb. Now we're going to work with the Spec 20. This is a spectrometer, which is a machine that's going to measure the absorbance and transmittance of the fluid that we're going to be using that we just diluted out to find our unknown concentration. So the first step to the spectrometer is, first off, you need to turn it on and let it warm up. To do that, you turn this knob here to the right, and it'll turn on. Now you'll notice it has 2 filters. It has a 600 to 950 nanometers and 340 to 599 nanometers. The first step you want to do is make sure your filter's to the right, and you want to set the wavelength, which shows up here, to 670. Now these knobs are really touchy, so if you move them a little, they'll actually move a lot. So you have to kind of finesse it a little bit, and you want to get it right at 670 for this lab. Now, with no tube in here, you want to make sure that you have your transmittance reading out at 0, and this will set your filter. So again, these knobs are really touchy, so a little goes a long way here. So you have a mode button here. You want to make sure that it's on transmittance when you're setting your filter up, and you want to make sure that it reads out for 0% transmittance. So this filter is now calibrated exactly for this wavelength of 670 nanometers. So once you have your filter calibrated, the next step is to zero out the wavelength with your blank here. So what you're going to do is you're going to take your blank, you're going to make sure you wipe off any fingerprints you have with a Chem wipe. And the next step is to line up the two lines. You'll notice here there's a white line here, and then inside your machine there's actually a line right here. So you just want to make sure that the lines line up. It'll stop. Close your lid. Now you have two options here. The first one is to zero this out to 100 transmittance or to 0 absorbance. They are the exact same thing. So for this example, we're going to go ahead and zero this out to 100% transmittance. Once this reads 100, you know that you have now calibrated for this wavelength, which in this instance is 670 nanometers. Once you have that done, you can go ahead and take your blank out, and then you will go ahead and load in your sample. When you go to fill your cuvettes, the most important thing you want to do is make sure that you just fill just to the bottom of the little circle here. So when you take your sample, just very carefully go ahead and pour it in till you get just below the circle. Once you've calibrated for your wavelength, the next thing to do is test your sample. So the same thing you did for your blank, you want to make sure you take your Chem wipe, wipe off all of your fingerprints that you may have put on here, which can interrupt with the reading. Line up the two lines. Close your lid. And the most important thing to do is not touch any knobs. The only thing you're really concerned with now is reading the transmittance and the absorbance. So for this reading, we're getting a reading of 84.4% transmittance, and then you hit the mode button, and that'll give you your absorbance reading, which is read in AUs. So this one is 0.073 AU. So with our standard curve, this is an example that's found in your book. What we are basically doing here is you're going to be making this best fit line with your known values. So you're going to have known values at this absorbance with this concentration. So the next thing you're going to do is you're going to take your unknown that you got from your dilution, from your unknown molarity. You're going to plug in and figure out what the absorbance is. You're going to follow it over to the best fit line and down, and that'll give you your concentration in moles per liter. Now for cleanup, the most important thing you want to remember is that none of this liquid goes down the sink, so you want to make sure that you carry it over to the waste beaker, which, and for our sake, we're just going to make our own beaker and we're going to carry it over there later. So it's very important that none of this goes down the sink, and you just want to make sure you get it all into your waste beaker. Now for your pipette, so the easiest way to clean your pipette is the same way that you were sucking up your fluid before. So you're going to squeeze the bulb and hold the A, and that'll get air in your bulb. And then go ahead and enter it into your water. Go ahead and suck up some water. Make sure you don't go up into the bulb. And then also you want to make sure you're expelling this in your waste beaker, not into the sink. So at the end, you'll notice there's a few bits of water here at the end. You want to make sure that you go ahead and get more fluid and repeat this process until it's clean. So that concludes our pre-lab video for the dilution lab. If you have any other questions, feel free to contact your lab supervisor.